Have you ever thought, nothing I do will make a difference, and felt your motivation drain away? In this video, we'll look at why that happens, what positive psychology researchers call learned helplessness, and how we can protect against it using immunization and the practices of learned optimism. By the end of the video, you'll be able to describe the core phenomena, interpret results of learned helplessness experiments, and identify practical strategies for maintaining a sense of control. Learned helplessness is when an organism learns that outcomes are not controlled by its responses, so the organism becomes functionally impaired by that expectation. In everyday terms, it's when the belief that my actions don't matter generalizes across situations. For example, a kid who struggles in Pee Wee soccer might conclude, I'm just bad at sports, and stop trying across all athletic contexts, despite there being lots they could do to improve with practice. The key idea here is that learned helplessness is a generalized expectation that your actions don't matter, not just a single failure. Recall that in Solomon and Wynn's 1953 shuttlebox experiment, when the light turned off, that was a cue that the floor where the dog was standing was about to become electrified. The first time a naive dog experiences the lights going out, it just stays put. What else is it going to do? 10 seconds later, the shock is presented, so the dog scrambles around until eventually the dog hops the barrier, which terminates the shock, or at least terminates the dog's experience of the shock. Over a few trials, the dog becomes quick and efficient. Soon, it jumps over the barrier the moment the lights go out and avoids the shock altogether. In several experiments, Seligman and colleagues repeated this avoidance training, but with one important difference. Some of the dogs in their experiments had a history of inescapable shocks. They had previously experienced shocks they couldn't control in a separate setup where nothing they did turned the shock off. When the light goes out in the shuttle box, initially, those dogs run around too. But then they stop, lie down, and quietly endure the shock. Even though a simple hop would work in the shuttle box, many of these dogs failed to escape or avoid. The learned expectation, nothing I do matters, carried over and shut down active coping. In a paper published in 1967 in the Journal of Comparative and Physiological Psychology, Overmyer and Seligman tested this phenomenon systematically. Some of the dogs first received unsignaled inescapable shocks, either 64 or 640 presentations, lasting a half second or 5 seconds, separated by 60 to 120 second intershock intervals. Those shocks occurred in a box with a single compartment. There was no barrier to hop and no way to escape the shocks. Other dogs simply spent time in that box with no shocks. Later, all dogs received escape avoidance training based on Solomon and Wynn 1953. A light turns off, and 10 seconds later, one side of the shuttle box becomes electrified. Hopping the barrier either escapes the shock if it's already started, or avoids it altogether if the hop occurs during the 10-second warning period. Dogs with no shock history learned quickly, first escaping, then avoiding. In contrast, many dogs with prior inescapable shock didn't learn the avoidance response at all. Only 1 out of 8 control dogs failed to jump the barrier, but 12 out of the 24 dogs in the 3 other groups with inescapable shocks never jumped. Those that eventually did learn to jump took much longer to do so. The history of uncontrollable aversive events produced a broad, generalized deficit in motivation and learning. We also see learned helplessness patterns in humans. For example, in one experiment with college students as research subjects published in the Journal of Personality and Social Psychology, Hiroto and Seligman adapted the shuttle box avoidance learning paradigm for use with college students. The regulations around what you could do to research participants were a little bit different in the 1970s, but even then, I don't think you could get IRB approval to put college students in small boxes, turn out the lights, and shock them, so the procedure had to change. Instead of shocks, participants in the experimental group were first exposed to inescapable loud noises, whereas participants in the control group were not. Later, all participants, that is, control and experimental group participants, were asked to solve anagrams. How do you think participants in each group did? Control group participants were generally able to solve all the anagrams. They were college students, after all, and they got better at it with practice. Experimental group participants, on the other hand, not only solved fewer anagrams than control group participants, but they took longer to solve the ones they did. Their performance with the anagrams looked a lot like the learned helplessness of the dogs that had been exposed to inescapable shocks. Hirota and Seligman's conclusion was that early experience with uncontrollable aversive events produces a sense of helplessness that carries over into other situations, leading to learning and performance deficits. The textbook mentions that other researchers have suggested that early adverse experiences where the individual lacks control can make people less likely to leave violent relationships and less able to cope with progressive illness, among other things. Research on learned helplessness continues, and patterns consistent with learned helplessness appear in several domains. Among healthcare workers in Morocco, higher self-reported helplessness correlates with lower psychological well-being. In the climate domain, higher learned helplessness predicts lower motivation to act. In education, students experiencing an effort-reward imbalance showed reduced academic engagement and attended fewer classes. Across these contexts and many others, perceived disconnection between effort and outcomes is associated with motivational costs. The theme is consistent. When effort feels disconnected from outcomes, motivation and performance suffer. At the neural systems level, learned helplessness appears to involve dysregulation of serotonergic brain circuitry. A simplified neural account focuses on serotonergic neurons in the dorsal raphe nucleus. Repeated uncontrollable shock drives dorsal raphe nucleus activity with projections to regions including the periaqueductal gray and the amygdala. Elevated serotonin release in the periaqueductal gray suppresses escape behaviors, promoting passivity, while input to the amygdala potentiates fear and anxiety. This network helps explain why uncontrollable aversive events can simultaneously produce passivity and heightened negative affect. Interestingly, the same serotonergic results engaged by uncontrollable events are also modulated by classic psychedelics such as psilocybin and LSD, which has led some researchers to explore them as potential treatments for helplessness-like states. That work is ongoing and tightly regulated. This is not clinical advice, just an emerging research direction. If helplessness arises when responses seem unlinked to outcomes, then early experiences of contingency can confer resilience. Immunization refers to arranging initial exposures to stressors so that signals are predictable and outcomes are controllable by the learner. Animals that first encounter aversive events under conditions of clear response-outcome contingency show greater resistance to helplessness later on. Comparable patterns appear in educational settings. When students begin with transparent criteria and rapid informative feedback, they maintain engagement more effectively when challenges do arise. Research on immunization has instructional implications for teachers, and we all step into that role at some point in our lives. You might not be a teacher yourself, but the advice can be adapted for parents, behavior technicians, people who train employees, coach athletes, or train in many other circumstances. The advice is to structure early tasks so that signals are clear and consistent, the response-outcome mapping is explicit, and so that learners can earn early, authentic wins that demonstrate control. Learned optimism is a set of cognitive and behavioral habits that frame setbacks as specific, temporary, and partially controllable. It is best understood not as a fixed personality trait, but rather as a set of practices. The goal for the learner is to preserve a sense of agency and to identify actionable next steps. Imagine this scenario. It's the beginning of a brand new semester. A student who has just returned to college after a long time in the workforce takes their first multiple choice quiz in years and gets a low quiz grade. They could take the low grade as evidence that I'm not cut out for this, which might make them less academically engaged, less likely to go to class, and generally less motivated to achieve. The belief that I'm not cut out for this becomes a self-fulfilling prophecy. Here are two other potential reactions to a low quiz score. I passed even though I'm out of practice. The next quiz will be more familiar. And I studied, but I could study differently. Maybe spend more time studying, make some flashcards, find a study group, or do a quick check-in with the professor. The event, that low quiz score, is the same, but these reactions preserve control and point toward changeable behaviors. Research also suggests that learners benefit from solution-focused narratives. In Sade and Woelfel's 2025 research on motivation to take climate action, participants who were exposed to constructive, actionable stories about working toward climate change reported decreased helplessness and increased motivation to act. Here are 5 practices you can implement to develop your own learned optimism. Number 1, challenge negative thoughts. Ask yourself, what evidence supports this view? What plausible alternatives might exist? Number 2, prioritize what you can control. Identify one concrete behavior you can perform within 24 to 48 hours. Number 3, practice gratitude regularly. Noting specific positives widens attentional focus beyond the individual setback. Number 4, cultivate supportive connections. Seek feedback, join peer study groups in academic settings, and make plans public for accountability. Number 5, set meaningful, bite-sized goals. Translate do better into clearly operationalized behaviors like review key terms for 20 minutes tonight or write 5 practice items. To conclude, recall that learned helplessness involves a generalized expectation that responses lack influence over outcomes. Like any habit, learned optimism is a muscle. The more you use it, the stronger it gets. We all face setbacks. Immunization and learned optimism both aim to restore or preserve the perception and reality of control. I invite you to take 1 minute now. Identify a challenge you're currently facing or a setback you anticipate as a possibility in the near future. List 2 elements of that challenge that are within your control. Specify one action you can take in the next 48 hours and commit to taking that action. Then name one person or community you can contact for feedback or support. The next time you encounter a setback, treat it as an experiment. Observe what changes when control is rendered visible and actionable, and see what shifts.